all you wanted to know about triangles. Which triangle is the coldest? And isosceles triangle. On our agenda, we're going to classify triangles by angles and sides. We'll name their parts, and we're going to learn 3 new theorems: the triangle sum theorem, isosceles base angle theorem, and the exterior angle theorem. So let's get ready. You're going to need your notes, pencil, and calculator. We'll start with some vocabulary, work our way through the theorems, and then do 6 examples along the way. When we are asked to classify, we need to think about what parts of a triangle are made up of. So when we classify them, we're going to classify them according to both angles and sides. It's going to take 2 words. So let's start with our angle words. We could have a triangle that has 3 acute angles. 3 acute angles. And therefore, we would call that an acute triangle. We could have an obtuse triangle. So think about that for a minute. If I have an obtuse angle, that means greater than 90. Could I have another obtuse angle? No, you could try to draw it, but it's not going to work. This has to close this way. So you could only have one obtuse angle in any triangle. We could have a right triangle, and that means it's going to have a right angle. Can it have more than one right angle? Nope, because we have to close it, so it will just have one right angle. And then the other thing is we could have a triangle that has all the angles being congruent to each other. We know that those all add up to 180, so 180 divided by 3 is 60. This is called equi for equal, angular for angle. And this has 3 congruent angles, and they all equal 60 degrees. We can classify according to the number of congruent sides. So if I have a triangle kind of like that, and none of the sides are marked, then we call that a scalene triangle. That has no congruent sides. If I have a triangle and it has 2 congruent sides, that's going to be our isosceles. 2 congruent sides. And if we have a triangle that has all 3 sides congruent, that's going to be called equilateral. Lateral means side, so we have 3 congruent sides. We can put that together and we can classify these using 2 words. So in my first one, I have all the sides are the same, so that's going to be equilateral. All the angles are the same, so that's going to be equiangular. And when we put those 2 together, we get even a more specific vocab word. This is a regular triangle. The word regular seems kind of boring, but it's actually important. It means that the figure has all the same sides and all the same angles. In our second triangle, I do have a right angle box, so this would be right. I don't have any marks on my side, so I can't assume. I'm going to call it scalene. On the third one, I have acute angles, and it's isosceles because 2 of the legs are congruent. In this one, there are congruent marks, but none of them match each other, so this is an obtuse scalene. This is a little hard to read, but this says less than 90, so this is an acute scalene. And this says greater than 90, so we have another obtuse scalene. Let's look more closely at isosceles triangle and name some of its parts. So we said isosceles triangle has 2 congruent sides. Those specific sides are called the legs. So it has 2 congruent legs. The other side is called the base. And keep in mind that base does not mean bottom, doesn't have to mean bottom. This could be the base over here with 2 congruent legs like that. And then angle A and angle C, they are sort of surrounding the base, so they are called base angles. And then our last angle up top, angle B, is called our vertex angle. Notice this would be my vertex angle over here. Let's look more closely at a right triangle. So we know it's a right triangle because we have our right angle box. Across from the right angle is our hypotenuse. Hypotenuse. That's our longest side. And then whatever's not the hypotenuse, our other 2 sides, are also called our legs. So a right triangle will have a right angle, a hypotenuse, and two legs. Let's look a little more closely at what happens. With the hypotenuse, it always has to be across from the right angle. So it is across from the right angle. And it's always the longest side. That's going to be important as we start to solve these triangles. Now let's look at angle A and angle B, keeping in mind that C is already 90 degrees. Well, we already have one 90-degree angle. I can't have another, and I can't have an obtuse. So A and B both must be acute. And then if angle C is already 90, A plus C has to equal 90. And when we have two angles that add to 90, we call them complementary. So they must be complementary as well. Let's look at some new triangle theorems. We're going to start with the triangle sum theorem. We've done this a little bit already. In class, I would have you take a triangle and rip off the three corners and then draw a line and see if you could match those corners up. There's the little rip. There's the little rip. Oops, that's supposed to be down there. And then what happens is it fills the line. So we prove that the sum of three angles of a triangle will always equal 180. That is the triangle sum theorem. The measure of angle A, it's been a little while since we've used that notation, plus the measure of angle B plus the measure of angle C equals 180. So you can write that out each time and fill in what you know. So here we have the measure of angle A is 120, the measure of angle B is 34. I don't know the measure of angle C, or you could say call it X, equals 180. I'm going to combine like terms, so I have 154 plus X equals 180, and then I'm going to subtract the 154, so I get 26. So that angle must equal 26. I'm going to use my notation. The measure of angle C equals 26 degrees. Could get a little more challenging. I have three angles. I know that they have to add to 180. I'm going to use my parentheses just to make sure I have the full angle. So 7x plus 8 plus 7x minus 1 plus 5x plus 2 equals 180 degrees. From here, we're going to combine like terms. So I have 7x, 7x, 5x. So that's going to be 19x. I have 8 minus 1 is 7, plus 2 is 9, equals 180. I'm going to subtract 9 from both sides, and I get 171. I'm going to divide by 19, and I get x to be 19. The isosceles base angle theorem. It says, in an isosceles triangle, if both legs are congruent, then both opposite angles, which we'll find out will be the base angles, will be congruent. So if here I have an isosceles triangle, I know that the sides are congruent. The arrow means, therefore, the base angle. So opposite that angle, opposite that, those base angles are going to be congruent to each other. So here's a nice pretty picture, vertex angle, two legs, base angles, and then this bottom would be our base. Important note that the base does not always have to be on the bottom. I could tilt it. Here's the base, and here are our two congruent legs. So always orientate yourself with that picture first. We're going to go ahead and give it a try. I see my congruent legs. Therefore, this is my base. So that must be congruent to that. So I'm going to set those equal. I'm going to subtract, 42. Subtract x from both sides, and I get 2x equals 42, and x equals 21. Isosceles base angle converse. This goes back to logic, and what does converse do? Converse switches it, so switches the order. Converse says, okay, if the base angles are congruent, start with the base angles, then the legs must also be congruent. So we reverse our picture. Here my base angles are congruent, therefore I can conclude that my legs must be congruent. Exterior angle theorem. Well, first we have to figure out what an exterior angle of a triangle is. So if I have triangle ABC here, there would be 3 exterior angles. I could just extend one, and then this is the outside. Remember, exterior means outside, the angle outside. And what I know is that it must be supplementary to this angle B. It's a little confusing. I don't know why they put C there and B there, but it's supplementary to that. So we'll call that angle D. That is our exterior angle. If I plug in some numbers, let's call this 80, this 50, and this 50. You can see I made it isosceles. What does this one equal? Well, it's right next to a 150. These two have to be supplementary, so this is going to equal 130. So we have 130 degrees. How does this outside angle compare to these two far away angles? Well, right next to it, it's 50 because we know it's supplementary. But look, 80 plus 50 is 130. So this outside angle equals these two far away angles when we add them together. And that's where our exterior angle theorem comes from. The exterior angle of a triangle, what's this supposed to say, theorem, is the sum of the two remote angles. Remote means far away. So it's not the one touching it. That's the adjacent one. It's the two that are far away. So the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. That's going to help us figure out some problems. So I could do 64 and 45 and then figure out this one and then work my way to this one. However, I could apply the exterior angle theorem and just say that x has to equal those two. X has to equal 64 plus 45 according to the exterior angle theorem. So x is going to be 109. We could throw some algebra in there. So let's orientate ourselves. This is my exterior angle. These are my two remote. I'm going to add those to equal that. So I'm going to have 25 plus x plus 15 equals 3x minus 10. I'm going to combine like terms on the same side, so I get 40 plus x equals 3x minus 10. I like to keep my x, my variable, positive, so I'm going to subtract x from both sides. Get 2x minus 10. Add the 10. 50 equals 2x. Divide by 50. Oops, divide by 2. And x equals 25. Just to recap, we've got our vocabulary words for classifying by sides: scalene, isosceles, equilateral. Angle words: acute, right, and obtuse. Both of those would include equilateral, and then angle would be equiangular as well. The triangle sum theorem: all the angles have to add to 180. Isosceles base angle: if the legs are congruent, then the base angles are congruent. And the exterior angle theorem: the exterior angle equals the two remote. Nice job.